The warm-up says number one, we're going to graph the points from the table and then write the equation in slope-intercept form. So right 2 down 2, then we'll go just straight down to 3, and then left 2 down 4, and then left 4 down 5. So we have a line here. All right, so we need our slope and y-intercept. So you can either do the slope by going rise over run. So if we did that, that would be you can rise 1, run 2, or you can just take any 2 order pairs. Like let's say that I took these 2 order pairs and then just found the slope. So it'd be -2 minus a -3 would be +3 over 2 minus 0. So we're going to get 1/2. So we have 1/2 x, and it crosses the y-axis at -3 here on the graph, or right here. When x is 0, right here, that y value is your y-intercept, so it'll be -3. Number 2, identify the x and y-intercepts in this equation. So to do that, to find the x-intercept, we let y be 0, and to find the y-intercept, we're going to let x be 0. So if we let y be 0 here, basically we just cancel that out. So we have 4x equals 12. So 4x equals 12. And so 4 times what is 12? Well, that's 3. So we have 3 right there. Okay. Then if, let's say I erase that. So then if we want to find the y-intercept, we let x be 0. So basically we cancel out the x. So then we have -6y equals 12. So divide 12 by -6 and you get -2. Number 3 says find the value of the function f of x equals x squared plus 6 for f of -2. So you're going to put -2 in place of x. You square it. Make sure you put parentheses around the -2, put the square on the outside of the parenthesis, and then you add 6. You can also put this into your graphing mode and go to the table and look to see when x, because you're -2, when x is -2, what your y value is. So -2 squared, that's 4, and 4 plus 6 gives you 10. Number 4, find the slope. So here's your circle. I'm not going to circle because I'm afraid that I'm going to take away the negatives. And then we do our dash, line, dash. So we have 4 minus a -5, which will become a +5. And then we have -2 minus a -1 become a +1. So basically we have 9 divided by -1 gives you -9. Number 5, we're going to solve for y. So 4x minus 6y equals 12. So what we're going to do is we're going to take this 4x term and move it to the other side. Then we're going to bring down the negative with the 6y. And a positive 4x moved over becomes a -4x plus 12. Then we're going to go through and divide everything, every single term by the -6. So we're going to have y equals -4 over -6 is a positive 2/3 x. And 12 divided by -6 is -2. All right, so then what we're going to do now is we're actually going to get into the notes 22, which is investigating the slope. So on problem 1, you have y is equal to x. This is the linear parent function. It's one of the easiest linear parent functions to graph because your slope is 1 and your y-intercept is 0. That means it is a direct variation because it goes through the origin. So it's graphed. Right over here is where you see the linear parent function is graphed. So again, your slope on this one is 1. Whoa, where did my... There it is. Your slope is 1 and your y-intercept is 0. And so I've already graphed it for you over there. All right, let's take a look at problem 2. So your slope is 2. Your y-intercept is 0. And if you want to put this in your calculator, you can go ahead and do that. But if you have a slope that's 2, so basically that's up 2 over 1, up 2 over 1. So it looks like this over here. So you can see that it is steeper, okay, because it goes from a 1 to a 2. It's not flatter, it doesn't have the same slant. All right, let's take a look at the next one, at problem 3. And this time your slope is 4. Again, your y-intercept is still 0. So what we're going to do, come on now. Trying to move this down because I moved it up too far. All right, so your slope is 4. So that means you're going to go up 4 over 1, or you can go down 4 left 1. So then you can see the graph here, and you can see that it is steeper. So I was going to try 2. So there we go. That's 4 and that's 0. So you can see the color of the pencil. So again, this is still steeper because your slope is 4. So basically, you have a slope that's 1, a slope that's 2, and a slope that's 4. Now, let's take a look at problem 4, where you have the slope is 1/2. All right, so your slope is 1/2, and again, your y-intercept is 0. So we're going to go up 1 over 2 from the origin, up 1 over 2. So it's going to look like this. So, and again, we are comparing this to the linear parent function, okay? So we're comparing it to that black line. So when we compare it to the black line, it's going to be flatter. All right, now then, let's look at number 5. Number 5 has y is equal to negative x. So the slope is -1, and the y-intercept is still 0. So again, it's another direct variation because it goes through the origin. Now, I have it right over here. So you see that it's going to go the other direction. So on this one, it is going to be the same slant as your other one, but it's going to go in the other direction. Same slant, but it's negative. All right, let's take a look at number 6. Y equal -1/4 x. So -1/4, and your b is 0. So if we go down 1, right 4, or you could go up 1, left 4. Regardless, okay, don't do that to me. Stop. Okay. So this one is going to, because it's like -1/4, it is actually going to be flatter than your -1x. And it looks like problem 7 is right here. So it didn't get moved to the next page like it was supposed to, but it says, for the following equations, which one would have the steepest slope? So let's take a look. The steepest slope. So let's think about this. The steepest slope, it doesn't matter whether it's negative or positive. It's just going to be the slope that is furthest from 0. So like on this one, this is 4 units from 0. This one, it's a -2, but it's 2 units from 0. This one, it's negative, but still it's 8 units from 0. And then this one is just y is equal to 1/8. It doesn't even have an x with it. So that would be a horizontal line just barely above 0. So it is going to be letter C. Number 8, for the following equations, which one would have the flattest? Okay, so if the steepest was the number that was furthest from 0, the flattest is going to be the number closest to 0. So this is 2 units from 0. This, remember, we're just looking at the slope. That's 1 unit from 0. This is 3/8 from 0, which will be a decimal. And then this is 12 units from 0. So this letter C is your correct answer. All right, let's go ahead and take a look at investing the y-intercept along with I'm not for sure what it's supposed to say, probably along with the linear parent function. All right, so let's take a look at problem 9. We've got y equals x plus 2. So your slope is 1. Your y-intercept right there is 2. So when we're comparing it again to the linear parent function, our y-intercept is 2. So that's where we begin. And then we go up 1, over 1, up 1, over 1. All right, so this one, it's not steeper because the slope is the same as the linear parent function. Remember, the slope here is 1. The only thing that happens with this one, it's going to have the same slant. It's just moved up to the y-intercept of 2. Let's look at problem 10. So you've got your slope right here in front of x, it's 1. Your y-intercept is -3. So let's graph this one. So we're going to be at -3. And we're going to go up 1, over 1, up 1, over 1. All right, so guess what? Same slant. It's just moved down. That's the only thing different. They still have the same slant. I don't know where that green line is coming from, but it needs to be erased. Let me erase it because it's coming on to the next page. Okay. I didn't know if y'all saw that one or not. Oops. Okay, let's take a look at problem 11. So now we have, well, there it is again. Okay, stop. I'm having difficulties here. Technical difficulties. All right, let's take a look at 11. We have 2x minus 3. So our slope is 2. Our y-intercept is -3. So we start at -3. We're going to go up 2 over 1. Up 2 over 1. Up 2 over 1. So again, we start here at -3. Let's take a look at what that line looks like. So it says describe the slope. Well, it is going to be steeper. In fact, it's going to be twice as steep because it goes from 1 to 2. So twice as steep as the linear parent function. And describe the y-intercept. It's just going to be moved down 3. All right, let's take a look at problem 12. Change my color. Okay, so we've got our slope is -3, our y-intercept is 4. So we're going to start here at 4, and then we're going to go down 1, 2, 1, 2, 3, right 1, 1, 2, 3, right 1. I know it gets kind of, go. So the slope is negative and steeper. It's negative because it has a negative sign in front of it, and it's slanting negatively. It's negative, and it's steeper. As you remember, steeper is 3 units, the slope is 3 units from 0, unlike the linear parent function is just 1 unit from 0. And then the y-intercept is at 4. So it's moved up 4. All right. Now, 13 and 14 really don't have anything to do with the parent function. It's just kind of talking about some special lines, which we have discussed from the Test 6 review. So, on number 13, it says y is equal to 5. So that means what we would do is we would put a 5 here. And the slope, so it might be a little more helpful for us to graph this. Just sketch it on here. So if this is 1, 2, 3, 1, 2, 3, 4, 5. So if I plot the points, I go right 1 up 5, I go right 2 up 5, I go right 3 up 5. So this is a horizontal line, which means the slope, horizontal lines have a 0 slope. The z's are special, if you didn't get that. So your slope is 0, or you could do like 5 minus 5 is 0 over 2 minus 1 is 0. Your y-intercept, well, all the y values over here in this table are 5, and it goes through the y-axis at 5. So this is a horizontal line. All right, let's take a look at the next one. We have x equals negative 3. That means all the x values are negative 3. So if we graph this, so 1, 2, 3, 1, 2, 3. So, oops, I went the wrong way. Sorry. 1, 2, 3. That was stupid. Okay, so we're going to go left 3, up 1. We're going to go left 3, up 2. We're going to go left 3, up 3. So this is a vertical line. And vertical lines have a slope that's undefined. Vertical line is undefined. It's supposed to kind of rhyme. Your y-intercept, is there such thing as a y-intercept if it's a vertical line and it goes through the x-axis? So we would put NA. It is not applicable. All right, and that's all we have here. Sorry about that. I just moved that on you. I didn't mean to.